Okay, hi pre-calc kids. We are going to work on your review. So I'm going to kind of talk through what I'm going to do and how I would approach each problem. And then you can look at this at your leisure when you need help on the review. Okay, so we're going to start with problem 1. I am going to square everything here. So this is 9x, and that's 4 times 2, so that's 8, y squared, z to the 6th. Then I'm going to do the same thing over here, and I'm not going to worry about that x to the negative 2 just yet. And let's see, 2 cubed is 8. That is x to the negative 6, z to the 12th. So now for 8 times 9, that's 72. And then I'm just going to add, since everything's multiplying, common bases, I'm going to add their exponents. So this is going to be 72, let's see, 8 plus a negative 6 is x squared. There's no y in the second, so it's y squared, z to the 18th. And then once it's all and as simplified as possible, I am done. Okay, number 2, I am going to move these all to fractions in order to make this work. Well, I take that back, all except for the log. This is how I'm going to do it, and then I'm sure you're going to see easier ways. So this is going to be 1 over 9 plus 1 over 3 all times 3 to the 4th. That works, yeah. Okay. And then, let's see, this becomes 1 over 9 plus 3 over 9. And 3 to the 4th is 81. So that is 4 divided by 9 times 81 is 36. Because 9 and 81 reduced by 9. So 4 times 9 is 36. Number 3, I am going to change this 4th root to a 1/4. And then 12 times 1/4 is, and that's a really bad 1/4, is cubed. Over here on number 4, I am just going to multiply across. So I'm probably going to do some simplifying, because 6 divided by 3, that makes that 2. So I really have k to the 4th times 5/4. Well, those 4 and 1/4 drop, or not drop, but divide out. So I have k to the 5th. Okay. Next one, I'm going to distribute that. Actually, let's simplify inside first. So that's 6x squared divided by, 6 divided by 3 is 2. 6 minus 4 is x squared, and then it's over b to the 8th. Squared. So now I'm going to distribute that squared to everything. So that's going to be 4x to the 4th divided by b to the 16th. And then number 6, I am going to distribute that x to the negative 1/2. So I'm going to do some multiplying. So that is going to be negative 0.5 times 0.5, or sorry, negative 0.5 plus 0.5 is 0. So this is going to be 2. And then negative 0.5 minus 0.5 is not that, is negative 1. So then I'm going to have 2 minus 1 over x. And that's as much as you can do on that one. 7. Let's see, what are we doing on 7? Let me, let's see, 32 divided by 4 is 8. This becomes x to the first over y to the fifth. So 32 divided by 4 is 8. Negative 4 minus a negative 5 is a positive 1. And y cubed, or 3 minus 8 is a negative 5, so it stays in the denominator where the number is bigger. Okay. I want to check something on 8 really quick before we do it. So pardon my scroll. C to the 4th over 4. Let's see what's going on with that. Okay, so I have, oh, well, c to the negative 2 and c to the negative 2 are the same. So that's 2c to the negative 4 raised to the negative 2. And then distribute that negative 2. Well, that negative means just to move it into the denominator. So 2 squared is 4. And negative 4 times negative 2 is c to the 8th over 4. Okay, so in this one, I'm going to simplify inside first before I deal with the negative 2. So 2 over 7 can't be simplified. 5 minus a negative 1 is a to the 6th over 7b squared. So now I'm going to raise everything to the negative 2, which means I am going to distribute that negative 2 to every piece. So first of all, it flips, so that becomes, well, let me back up. Let's do this. Let's take care of the negative exponent, before we square everything. So let's make it 7b squared divided by 2a to the 6th. And now square everything, so that's 49b to the 4th over 4a to the 12th. And then nothing can be simplified, so it's as far as it can go. Same thing here. Let's do the, actually on this one, because there's negatives here and here, and I want to distribute. So what I'm going to do is I'm going to say, okay, negative 4 to the negative 3, x to the, what is that? And then we'll do it to that one. X to the 15th, z to the 6th. So now take care of that. And 4 to the 3rd, or negative 4 to the 3rd, is negative 64. So I have x to the 15th, z to the 6th over negative 64. Okay. Anything to the 0 power is 1, so that's gone. So I really have 25 z to the 6th to the 1/2. And that just means square root or times 1/2. So square root of 25 is 5. And then 6 times 1/2 is 3. And then here, same thing here. Except for I don't have anything to the 0 power. So cube root of 27 is 3. 3 times a third is 1. And 9 times a third is 3. So final answer is 3ac cubed. flip the fraction first on this one. So 3 over 5 raised to the third. That is 27 over 125. This square root, well, let me phrase that back up. Let's do the reciprocal for the negative. So I have 16 over 9 to the 3 halves. The denominator is your root, so to the square root. So that is 4 thirds. Raise it to the third is 64/27. Okay. 121x to the 1/7 to the 7 halves. 1/7 times 7 halves is 1/2 because the 7's divide out. So I really have 121x to the 1/2, 120. The square root of 121 is 11 square roots of x. Or you could have kept that raised to the 1/2. Both would have worked. Okay, we're on problem 16, and we just need to expand correctly. So the first thing I'm going to do is take care of that divide. Now remember, everything has to have a base of 7, and it needs to be a subscript. Okay. This 5 needs to be moved to the front, and these guys need to be split. And they are both split with a minus because the b is in the denominator as well. So log base, oops, not quite. Let me back that up. 5 log base 7 of x minus log base 7 of 3 minus log base 7 of b. And then that is your final answer on that. Here, we're going to raise both to the 1/2. Log base 5 of m divided by 6 to the 1/2. We're going to move the 1/2 to the front. Of m over 6. Now I need to split that subtraction. Now you can put the 1/2 in front of both, or you can do a 1/2 parentheses log base 5 of m minus log base 5 of 6. Either, and then I would expect you on that log base 5 of 6 to evaluate it if possible. If it's not possible, no worries. Now, you could distribute that 1/2, and that would be 100% good. I'm just choosing not to at this time. Same thing on 18. Move the 2 to the front. And I'll show you the distribute on this one. Split that a times b with a plus sign. So I have the 2 times the log of a plus 2 times the log of b. And then there you are. Okay, now we're going to simplify. In other words, write it as 1. So I move this 2 up and move this 3 up. Log base m of a squared minus log base m. Actually, well, a cubed. And then you could say log base m of a squared divided by a cubed, which would equal to log base m of 1 over a. You could definitely go that route. There was something I noticed after I got started. This is 2 log base m of a and 3 log base m of a. So you could have made that. Oh, I don't like that color for that. Negative log base m of a, and then you could have jumped down to that answer. Both ways are 100% correct. It just depends on how you see it. And the only way that green one works is because log base m of a is exactly the same in both. you notice in 20, that's not the case. So the first thing I'm going to do is move that 3 up. Oops, it's not a log on this one. It's a natural log. ln of A minus ln of B times C cubed. And now we just have to do the divide. Ln of A divided by BC to the third. You do not need to distribute that cubed. I know a lot of you on your quiz did, and it's fine, but you just don't have to. 21, notice that they are not the same arguments. You cannot do the subtraction or addition like you could in 19. But I could move that 3 up. So I have the log of y squared minus 7 plus the log y cubed cubed. So this, the plus sign means multiply. So log of, let's see, 3 times 3 is 9. So it's log of y to the 9th times y squared minus 7 in parentheses. And that's the end of that. I do not expect any more simplification on that. Okay. These are either evaluate into a whole number or use your properties and write as logs. Sometimes you just need to write as logs. And I'm going to keep everything in exact answers as much as possible. So 3 to what power is 9, and that is 2. No matter how I do it, 4 to any power is not going to be 5. So, oh, actually, let's look down at the bottom. What are they expecting? 23. Let's look down and see what the answers are. 23. Oh, change base formula. So they do want exact. So yes, let's do exact. Log of 5, because we want log of the argument, over log of 4. Let's see. What is 4 times 64? Yeah. 256. Log base 8 of 256. 8 squared. Let's back that out. And let's do, because that's 2. Let's see. No matter how I slice it, that's not going to work. How do I want to, let's look and see what they want on the answers. I'm hoping the instructions are much better. I don't even know what number we're on. We are in number 24, so excuse my scrolling. Let's see, 256 divided by, 256 divided by 8 is 32. Okay, well, that's getting somewhere. That's not really getting anywhere. Let me rephrase that sentence. That's not getting anywhere. Oh, I know what we could do. Let's back life out. Okay, let me back out. Okay, log base 8 of 64, that is 2. To go from 8 to 4, for the 4, that's 2. Oh, y'all, sorry, Miss Stigner's having all kinds of stuff. That's log base 2 cubed of 2 squared plus log base 2 cubed of 2 to the 6th. There you go. Because 8 is 2 cubed, 4 is 2 squared, 64 is 2 to the 6th. So log base 8 of 2 to the 8th will get me 256. Okay. And then 8 log base 8 of 2. Well, log base 8 of 2, 2 to what power, or 8 to what power would get me 2? Well, 8 to the 1/3 would get me 2. So this becomes 8 times 1/3. That was way convoluted, y'all. Is equal to 8/3. That was a hard one. I will admit that with you. That was hard. There's no way 12 is going to get me 14. There's nothing even remotely in common. So log of 14 divided by log of 12. When you can't get anything common on these problems, do change a base formula. Oh, look, we have change a base, sort of change a base formula. Log base 2 of 32, so 2 to the 5th power is 32. And then 3 of 27, 3 to the 3rd power is 27. So this becomes 5 and 3. This is no solution because you cannot take the log of a negative argument. Natural log of E is 1. And then E to the ln of 4 plus ln of 5. And that's E to the ln of 20 by property standards, and we have an identity that says if we have base raised to a log with the same base, then it is just the argument, which is 20. So all of these either use some sort of properties. This one used, number 24 used multiple. 24 was the hardest on that. But other than that, they were pretty good. Okay, so now we're going to solve. And again, think about this as, yes, you're going to get a calculator, but you can't use your calculator 100% of the time. So what we are going to do is we are going to get bases alike on this first one. So that is 5 cubed to the 2x times 5 to the x is equal to 5 squared cubed. So this is 6x plus x is equal to 6. That becomes 7x is equal to 6, so x is equal to 6/7. And then I would type it in my calculator and I would check it. Or, no, that's what I would do. 10 to the 1/6 times 10 cubed is equal to 10 to the x divided by 3. So then I have 1/6 plus 3 is equal to x over 3. That's 3 and 1/6. 18, so that's 19/6 is equal to x over 3. So times 3. So x is equal to 19 divided by 2. That seems really far off, so I'm going to check my answer down below. What number was that? 31. 31. Nope, it's right. It just seemed off. Sometimes that happens. Okay, multiply first. Use that property. So log base 5 of x times x minus 4 is equal to log base 5 of 5. So I have x squared minus 4x. In other words, I'm going to get rid of the logs is equal to 5. X squared minus 4x minus 5 is equal to 0. I'm going to factor into x minus 5 and x plus 1. X is equal to 5. X is equal to negative 1. And the negative 1 is extraneous, so it won't work. Here's 5. And that's the end of that. So this next one is for 33, 34, and 35. These are your literal problems from Friday. So the first one, we're going to solve for P. So I have 2 log of n is equal to r plus P. 2 log of n minus r is equal to P. And that problem is done. And then I want to solve that same problem, but this time for n. So 2 log of n is equal to r plus P. Log of n is equal to r plus P divided by 2. Rewrite that into exponential. So 10 to the r plus P divided by 2 is equal to n. And there's your equation. Okay, solve for W. So my common denominator in this one is W, X, and Y. So I have XY minus WY is equal to WX, and I want to solve for W. So I need to move this WY to the right. So I have XY is equal to WY plus WX. Factor out AW, Y plus X. So W is equal to XY divided by Y plus X. And then now we want to solve for Y. So I'm still going to use that beginning equation of XY minus WY is equal to WX. Factor out a Y this time. And I get WX. Y is equal to WX divided by X minus W. Okay, next one, we're going to solve for capital A, so factor out an A. You're left with C plus B is equal to 4. A is equal to 4 divided by C plus B. On the second half, we want to solve for B. So I have 4 minus AC is equal to AB. And I am going to divide by A. And no, I cannot divide those out because the A is not in every term, so we are stuck with it. Okay. Here we're going to use properties and the numbers they gave me. So log base B of 20 is 4 times 5. So that is the log base B of 4 plus the log base B of 5. So that is 2.1 plus 6.2, which is 8.3. Okay. 125 is 5 divided by, log base B of 5 divided by 4. the log base b of 5 minus the log base b of 4. So it's 6.2 minus 2.1. It's 4.1. And then 16 is 4 squared. So that is 2 log base b of 4. So that is 2 times 2.1 is 4.2. Okay, that is it for that section. And then the last handful we have are all of our growth decay problems. So a population is 95,000 people. It increases at a rate of 3% per year. How long until the city has 20,000 people? So my equation to start, 21, 2, 3 is equal to 95,000 times 1.03 to the x. So first thing, oh, and that's 200,000. So first thing I'm going to do is take that 200,000 and divide it by 95,000. And I get some gross number. So I'm going to actually leave it as a fraction. And then I am going to do the log of both sides. So I'm going to do the log of this big number. Well, it's not that big. It's actually really small, but and then I'm going to move that x down to the front, and I'm going to divide. So I have x. Well, let's do it step by step so you can see it. So I still have the big fraction over here. And actually, I'm going to cut it down a little bit. Of 200 divided by 95 is equal to x times the log of 1.03. And then I'm going to divide by the log of 1.03. Oops, I did not leave myself room. So it's like the change of base formula. And then I'm going to put it in my calculator. And I get 25.185 years. So it's going to take that long for it to grow. Okay, we have a population of a town is 170. It decreases at a rate of 4% per year after 4 years. So y is equal to 170,000 times 1 minus 0.04 to the 4. And then there is no solving for me on this one. This is just type it into the calculator. Oh, no, not 1. Make sure you do the subtraction and not addition, because if it grows, then that's a problem. So I got for an exact 144,388.915. And since we're talking about people, we're going to round this appropriately to 144,389 people. Okay, and then we're going to get into an investment problem. You invest $200 today, the account earning 4% interest compounded daily. Now remember, daily is 365. How long will it take for your account to double? So we want $4,000 to equal 2,000 times 1 plus 0.04 divided by 365 raised to the 365x. excuse me. So first thing we're going to do is divide that by 2,000. And so we get 2 is equal to, and then I am, that inside the parentheses, I am going to evaluate that in my calculator. And I get something not super great, but it works out to be 0.0001. Here's the thing. I am going to use, even though I wrote this on the 1.0001 on my paper, I'm going to use what's in my calculator in the exact answer when I go to evaluate it. And then I'm going to do like I did up above and do the log of both sides. So I have the log of 2 is equal to the log 1.0001 to the 365 times x. I am going to move that 365 times x to the front. Oops, not that. And then I'm going to divide. So I really have x is equal to log of 2 divided by the log of 1.000 times 365 in the denominator. Okay, and then I'm going to type that in my calculator since we don't need an exact answer. And actually I'm going to use my fraction button. And this is where going up to grab your, ooh, that is not where I want that. Well, it's not going to work the way I want it to. I ended up having to keep it in the fraction for my calculator to work correctly. And we got 330 years. And actually I kept this, so I'm going to go backwards and erase this and fix it. Because I ended up keeping it so that my calculator would work as 1 plus 0.04 over 365. And then 1 plus 0.04. So I'm just fixing all of those to be the same fraction I had when I started. Because it didn't pull the answer where I wanted it. Okay, so there's your final. Okay, half-life of a certain element is 15 hours. There are 50 grams present now. When will there be 12 remaining? So 12 is equal to 50 times 0.5 to the x divided by 15. So the first thing I'm going to do is divide by 50. It's 0.24. I cannot get those exponents equal. And I could just rewrite it as log base. And since these are not very big decimals and they're not long, that's not that bad. But the other ones, because some of the stuff was longer, it was easier to write it. It was to take the log of both sides. So x is equal to 15 times the log base of 0.5 of 2.24. And then I'm just going to go to the calculator. And I got 30.883 years. No, not years, hours. So just over a day, a little bit over a day. Okay, if you invest $1,300 today in an account earning 3.2% compounded continuously, how much will be in your account after 4 years? Again, this is just to type it in. Interest rate is 0.032 times 4. And you get, and remember it's money, so it's $104 or $1,477.52. Here's your answer. I do want to check on something up here. How long? So this one's not money because we're talking about how time. This one is money, so round appropriately. If you have questions, reach out. Don't forget there's tutorials.